Hello there, and welcome to Cosmos for Sleep. Tonight, we're journeying to the Red Planet, exploring the fascinating facts about the colonization of Mars. If these calm, curious explorations help you unwind, consider liking and subscribing to the channel. It helps others find their way here too. For now, just breathe. Let your eyes grow heavy, and let's begin. The grand vision of Mars colonization involves transforming its entire environment, a process known as terraforming, which aims to slowly make the planet more Earth-like over thousands of years, potentially creating a breathable atmosphere and flowing water. This extensive process would reshape Mars, but before such a grand transformation can occur, the planet's fundamental vulnerabilities must be addressed with careful foresight. One critical step involves the potential creation of an artificial magnetic field designed to protect future Mars colonies from the constant barrage of solar and cosmic radiation. Mars, our celestial neighbor, gracefully lost its global magnetic field billions of years ago, a distant event that left its surface perpetually vulnerable to the harsh, unfiltered energy streaming from the sun and beyond. Thoughtful future plans are now considering innovative ways to generate an artificial magnetosphere, an intricate, subtle shield that would safeguard pioneering human settlements from these pervasive and potentially damaging cosmic influences, allowing life to flourish more serenely on the surface. Fortunately, Mars graciously offers vital natural resources that are essential for such ambitious endeavors. The planet possesses an astonishing abundance of water ice, found both at its serene polar regions and hidden beneath its reddish surface. Scientists estimate there is enough of this frozen water to fill a body the size of Lake Superior, a truly immense reserve. This precious, abundant water is a crucial resource for any colonization effort, providing not only the fundamental drinking water for future inhabitants, but also a source for producing breathable oxygen through electrolysis and yielding hydrogen, a potent component for rocket fuel, allowing for a more self-reliant presence. Accessing, purifying, and processing this vital water will be a fundamental and continuous task, sustaining life and operations with quiet efficiency. For immediate protection and secure habitation, humans could find safe refuge and establish their initial dwellings in the vast, ancient underground lava tubes that honeycomb parts of Mars. These natural tunnels, gently carved by ancient volcanic activity over eons, offer ready-made and robust protection from the harsh Martian surface environment. Within their quiet depths, colonists would be shielded from the relentless flow of cosmic radiation and the abrasive planet-wide dust storms, while also benefiting from more stable and moderate temperatures compared to the extreme surface fluctuations. These subterranean havens represent a serene and secure foundation for early settlements, offering a tranquil start. Looking beyond immediate survival and resource needs, the very act of colonizing Mars serves a profound and far-reaching purpose by creating a backup plan for humanity. This thoughtful expansion beyond our homeworld ensures our long-term survival and resilience against potential Earth-bound catastrophes. Establishing an off-world presence provides a gentle safeguard, protecting our species from unforeseen, large-scale events such as devastating asteroid impacts, powerful supervolcano eruptions that could alter Earth's climate dramatically, or even widespread global conflicts that might arise, offering a tranquil sanctuary for human life to continue its journey among the stars. This forward-looking perspective gains depth when we consider that Mars once had a much thicker atmosphere and an abundance of liquid water flowing freely across its surface. Evidence gently suggests a warmer, wetter Mars existed billions of years ago, a time when conditions were potentially far more hospitable, even suitable for the emergence of life. This ancient, serene history offers invaluable clues and inspiration for our future terraforming efforts, guiding us in understanding how to coax the red planet back to a more verdant state. Despite these hopeful echoes of a past environment, the current Martian landscape presents a stark and challenging reality. The average temperature on Mars hovers at approximately -81 degrees Fahrenheit, a chilling embrace that demands robust and sophisticated heating systems for any human habitats. Future colonists will require meticulously designed, exceptionally well-insulated, and consistently heated living spaces to serenely survive the extreme, pervasive cold that defines much of the Martian surface. Every structure must be a carefully crafted haven against this deep chill. Another significant consideration for sustainable living involves the Martian soil, or regolith. This reddish dust, while abundant, contains perchlorates, which are toxic compounds. These chemicals, naturally present across the Martian landscape, pose a significant challenge for agriculture, as they must be carefully removed or neutralized before edible plants can be safely grown directly in the soil. Innovations in hydroponics or advanced purification methods will be essential to cultivate nourishing food sources without risk. To power these complex habitats and industrial processes, generating sufficient energy on Mars will likely involve a thoughtful combination of several reliable sources. Solar panels, designed to capture the sun's distant light, will be crucial, complemented by the steady output of nuclear energy for continuous operation, and potentially even harnessing geothermal energy from the planet's internal warmth. This diverse array of energy sources is needed to support the intricate network of systems required for complex habitats and the various industrial processes necessary for self-sufficiency, ensuring a steady and reliable flow of power. Amidst these practical considerations, Mars also holds natural wonders of immense scale. The planet is home to Olympus Mons, a colossal shield volcano that stands as the largest volcano in our entire solar system. Its gentle slopes rise to a height 3 times greater than that of Mount Everest, a truly majestic geological feature that speaks to the planet's dramatic and powerful past. This impressive landmark offers not only a testament to Mars's ancient dynamic forces, but also a compelling site for future scientific exploration and study, revealing the deep history etched into its surface. As humanity reaches across the vastness of space to Mars, the challenge of communication presents a unique rhythm. Communication with Earth will always carry a time delay, a silent pause ranging from 3 to 22 minutes for a one-way message, depending on the orbital positions of the two planets. This inherent delay makes real-time, fluid conversations impossible, necessitating a shift towards asynchronous communication strategies and fostering an environment where independent, thoughtful decision-making is paramount for colonists. The gentle cadence of delayed messages will shape the social interactions and operational protocols, encouraging a patient and reflective approach to collaboration. Over generations, this separation and unique environment could gently foster the development of distinct cultural norms and even a unique accent among future Martian societies. Living on another world, far from Earth, has the potential to cultivate a new identity and a unique way of life for those born and raised under the reddish Martian skies. This gradual evolution of culture would add a rich, new chapter to the human story, a serene unfolding of identity in a new cosmic home. Before humans embark on this grand journey, robotic missions serve as essential precursors, gracefully paving the way. These tireless rovers and orbiting spacecraft are meticulously mapping the planet's surface, scouting potential settlement sites with precision, and diligently testing critical technologies. By gathering invaluable data, these robotic explorers pave the way for human exploration, ensuring that when the time comes, our steps on Mars are taken with informed confidence and careful preparation. Their silent work is foundational to the future. The first human missions to Mars will likely involve small, dedicated crews living in compact, highly protected habitats. These initial outposts will be meticulously designed to prioritize survival, enabling focused scientific research and methodically proving the core concepts of long-duration colonization. These early settlements will be modest, yet vital, foundations from which humanity's presence on Mars can gently and steadily expand, demonstrating the viability of life beyond Earth. While Mars currently lacks a global ocean, the planet holds vast quantities of subsurface water ice hidden beneath its surface, waiting to be gently awakened. These immense reserves could one day be carefully melted and collected to form new lakes, or even small seas, a truly transformative process. This ambitious step would be a key element in the broader vision of terraforming, gradually creating open bodies of water that could support future ecosystems and enhance the planet's overall habitability, nurturing a new blue horizon. For sustaining life within these habitats, growing algae for food and biomass could prove to be an exceptionally efficient and sustainable solution within Martian greenhouses. Algae farms represent a compact and potent food source, capable of providing essential protein and simultaneously producing breathable oxygen as a byproduct of photosynthesis. These miniature, self-contained ecosystems offer a practical and sustainable method for nourishing early colonies, minimizing resource consumption with elegant simplicity. The inherent absence of a breathable atmosphere on Mars means that all human activity outside the protective confines of habitats will require the constant use of full-pressure suits. These specialized suits, while essential for survival, are inherently complex and somewhat restrictive, limiting mobility and potentially increasing the risk of accidents during extravehicular activities. Colonists will need to adapt to these constraints, moving with measured grace in their personal life-sustaining bubbles. As humanity contemplates life on another world, profound ethical considerations gently arise. These include the vital task of protecting any potential Martian microbes from contamination originating from Earth, and, equally important, safeguarding Earth from any potential alien biological elements. Strict planetary protection protocols are absolutely vital to prevent harm to any indigenous Martian life forms that might exist, however microscopic, and to conscientiously safeguard our home planet from unforeseen biological risks. This dual protection ensures responsible interstellar stewardship. The monumental task of creating an Earth-like atmosphere on Mars would involve the gentle release of trillions of tons of greenhouse gases into the thin Martian air. This ambitious and deeply patient endeavor would require centuries, perhaps even millennia, of sustained effort, involving industrial-scale atmospheric engineering to slowly warm the planet and thicken its atmospheric blanket. It is a testament to long-term vision, a gradual awakening of a dormant world. Mars's thin atmosphere also contributes to extreme temperature swings between its days and nights. Without a thick atmospheric blanket to trap warmth, heat radiates away quickly after sunset, leading to dramatic drops in temperature, often by more than 100 degrees Fahrenheit. This stark thermal contrast demands highly resilient materials and dynamic environmental controls for all surface structures, ensuring a stable and comfortable internal climate. Paradoxically, Martian gravity, which is approximately 1/3 of Earth's, could offer unique benefits for certain industrial processes. This reduced gravitational pull might allow for the construction of larger, lighter structures than would be feasible on Earth, and could enable novel construction techniques and more efficient material handling. The gentle embrace of lower gravity could thus unlock new possibilities for engineering and industry, shaping the very architecture of a future Martian civilization in elegant new ways. However, before these grand structures can rise, the journey itself presents its own intricate set of challenges. The long journey to Mars requires exceptionally advanced life support systems, meticulously designed to recycle air, water, and even waste almost perfectly within a closed-loop environment. These closed-loop systems are not merely beneficial. They are absolutely critical for ensuring sustainability, both during the months-long space flights and within the nascent colonies themselves. Every molecule must be conserved and reused with utmost efficiency, forming a delicate and self-sustaining cycle. As the journey progresses, or as a permanent presence is established, Mars's two small moons, Phobos and Deimos, could serve as serene and strategic staging points for orbital operations. These diminutive celestial bodies, silently orbiting their parent planet, offer potential sites for distant observation, for the careful extraction of valuable resources, or for establishing scientific outposts that extend humanity's reach just beyond the Martian atmosphere. Their presence provides convenient stepping stones for more complex missions. Looking back at our home world, the very aspiration of colonizing Mars could, in a beautiful cosmic irony, spark a new era of profound technological innovation and economic growth on Earth. The immense challenges inherent in living and thriving on another planet act as powerful catalysts, driving breakthroughs in materials, science, energy, and life support that will ultimately benefit humanity universally, enriching our lives even here on Earth. This distant endeavor creates a ripple of progress that flows back home. Returning to the planet itself, while Mars holds abundant water ice, this vital resource is often found mixed with the pervasive Martian regolith, or Mars dirt. This intimate blending requires energy-intensive processes to carefully extract and then purify the water. Specialized equipment will be needed to process this dirty ice, separating the precious water for drinking, breathing, and fuel, demanding ingenious solutions for resource management. Building a truly sustainable Martian colony will, by its very nature, require a wonderfully diverse skill set among its inhabitants. From meticulous engineers and insightful scientists to patient farmers and skilled doctors, a wide range of expertise is absolutely essential for cultivating a truly self-sufficient and thriving community. Each individual, with their unique contribution, will weave into the rich tapestry of this new society. The first permanent human presence on Mars is envisioned not as an immediate metropolis, but rather as a modest research station. This initial outpost would gradually and thoughtfully expand into a small, pioneering town over time. The earliest efforts would focus intently on scientific exploration, seeking to understand the planet's secrets and on proving the long-term viability of human habitation, laying a careful foundation for future growth. A persistent environmental concern on Mars is the threat of micrometeoroid impacts. Protecting colonists from these small, fast-moving space debris particles will require robust habitat designs, incorporating layered shielding and advanced warning systems. Even tiny fragments of space rock can pose a significant and silent threat to the integrity of pressurized environments, necessitating constant vigilance. Another fundamental challenge stems from Mars's greater distance from the Sun compared to Earth. This orbital position means the red planet receives significantly less solar energy, posing a challenge for power generation. To compensate, much larger solar arrays will be needed, or alternative power sources such as advanced nuclear fission reactors. Interior will be required to support complex habitats and industrial operations. Despite these hurdles, the potential rewards are vast. The careful mining of Martian resources could gently lead to the development of unique industries and the birth of a new, vibrant space-based economy. Beyond Mars itself, asteroid mining and lunar resources could also integrate seamlessly with a burgeoning Martian economy, creating an interconnected network of off-world commerce and innovation, a quiet expansion of human enterprise. As humanity reaches for the stars, the legal framework for Martian colonization is still gracefully evolving. Addressing complex issues of sovereignty over newly settled territories and the equitable rights to planetary resources will require the thoughtful development of international treaties and agreements. These will be essential to govern off-world settlements with clarity and fairness, ensuring a peaceful and ordered expansion into the cosmos. A key reason for Mars's harsh environment lies deep within its structure. Mars does possess a core, but unlike Earth's, it is not generating a global magnetic field strong enough to protect its surface. The planet's internal dynamics differ significantly from Earth's, a subtle yet profound difference that has directly impacted its geological and atmospheric history, leading to its current state of vulnerability. in the long-term vision of terraforming. One method involves the gentle release of stored greenhouse gases from the Martian regolith and its polar caps. This measured release would gradually warm the planet and thicken its atmosphere, initiating a positive feedback loop that slowly transforms the environment over eons. It is a patient dance with planetary processes, coaxing a new climate into being. A direct consequence of Mars's atmospheric conditions is the lack of an ozone layer. This means that unfiltered solar ultraviolet radiation is a constant and pervasive threat to any life on the surface. Any surface activity or life forms would require extreme protection from these harmful rays, making robust shielding a non-negotiable aspect of every design. Adding to the environmental complexities, the pervasive dust on Mars is not only fine, but also electrostatically charged and highly abrasive. This unique combination makes it potentially damaging to sensitive equipment and poses significant health risks to colonists, particularly respiratory issues. Martian dust, though seemingly innocuous, is finer than talcum powder, yet remarkably corrosive to machinery, demanding careful mitigation strategies. Given the immense challenges and profound isolation of life on Mars, psychological screening and rigorous training will be crucial to carefully select resilient and adaptable colonists. The mental fortitude required for such an endeavor is truly immense, demanding individuals capable of profound inner calm and enduring strength amidst unprecedented circumstances. Fortunately, Mars possesses significant quantities of valuable elements within its rocks, including iron, silicon, and aluminum. These fundamental elements could be extracted and processed locally, providing the raw materials necessary to build habitats, craft tools, and support the burgeoning industries of a Martian civilization. This local availability of resources simplifies the challenge of self-sufficiency, offering a solid foundation for growth. To truly build a self-sustaining presence on this distant world, the meticulous development of closed-loop ecosystems will be absolutely essential for long-term food production and comprehensive waste recycling. This ambitious endeavor involves gracefully mimicking Earth's intricate natural cycles, where water, air, and nutrients are continuously purified and regenerated, but within a confined, artificial environment. Such a delicate balance represents a major engineering challenge, requiring profound ingenuity to ensure every precious resource is continuously sustained and reused with utmost efficiency, forming a serene and self-perpetuating cycle vital for enduring life far from home. Before establishing such intricate, self-sustaining systems on the Martian surface, the journey through the vastness of space itself must be carefully navigated. The voyage to Mars typically takes between 6 and 9 months, a precise duration that depends gracefully on the optimal orbital alignments of Earth and Mars, dictating the most energy-efficient transfer windows. This extended travel time presents significant and subtle challenges for crew health, including the prolonged exposure to microgravity, which can lead to bone density loss and muscle atrophy, and the pervasive, low-level radiation environment of deep space. Furthermore, it demands meticulous planning for mission logistics, ensuring all vital supplies, psychological well-being, and operational readiness are maintained throughout the silent, deliberate transit across the void. Upon a successful arrival, Mars gently unfolds as a pristine and compelling environment, an unparalleled laboratory for scientific research. Its relatively untouched surface holds invaluable clues to the grand processes of planetary formation, revealing the deep, ancient history of our solar system, and presents the profound, captivating possibility of past or even present microbial life. From the intricate studies of Martian geology and atmospheric dynamics to the exciting and contemplative field of astrobiology, Mars promises a wealth of discoveries that could gracefully reshape our fundamental understanding of the universe and our place within it. It is a world awaiting silent revelations. For those pioneering individuals who make the arduous journey, a unique and deeply personal psychological shift gently awaits. Known as the overview effect, This profound cognitive change, typically experienced by astronauts viewing the serene blue marble of Earth from the vastness of space, could similarly impact Martian colonists. This distant, solitary perspective often fosters a powerful and unifying sense of global interconnectedness and a renewed, tender environmental responsibility, gently reminding settlers of their profound connection to their distant home planet, fostering a quiet reverence for life. However, the very act of arrival on Mars is not without its intricate difficulties. Mars's thin atmosphere, while offering a subtle buffer, makes landing large spacecraft particularly challenging. It requires highly advanced braking techniques, as the atmosphere is simply too tenuous for the kind of effective aerodynamic braking systems routinely employed for atmospheric entry on Earth. Yet, it is just thick enough to cause significant drag and heat buildup, demanding precise control, robust design, and graceful maneuvers for a safe and successful descent onto the reddish plains. Establishing a truly self-sufficient and thriving colony on Mars is not a swift endeavor. It is a patient, long-term project that could gently unfold over many decades, involving the dedicated efforts of multiple generations of settlers. It requires sustained commitment, continuous and thoughtful investment, and the unwavering dedication of people committed to building a new home, one slow, deliberate, and meticulous step at a time. This profound generational commitment beautifully underscores the immense and patient scale of the undertaking, a quiet legacy in the making. In this new gravitational environment, where the pull is roughly 1/3 of Earth's, the low gravity on Mars could elegantly allow for the easier construction of remarkably tall structures, or impressively large, expansive domes. The engineering limitations and creative possibilities would be wonderfully different from those encountered on Earth, opening entirely new avenues for architectural design and urban planning. This unique condition allows for the conception of expansive and innovative living spaces that reach gracefully towards the Martian sky, fostering a distinct Martian aesthetic. Central to the very possibility of sustainable life and growth, sophisticated water processing plants will be absolutely vital on Mars. These meticulously designed facilities will carefully purify extracted ice, transforming it into potable water, and diligently recycle all wastewater generated by the colony's inhabitants and operations. Every precious drop of water, from personal consumption to industrial processes, will be treated with the utmost care, becoming a continuously recycled and revered resource. A silent testament to the essential and life-giving value of this element on an arid world. The very atmosphere of Mars presents an immediate and critical danger to human life. The planet has an average surface pressure that is less than 1% of Earth's, effectively rendering the surface environment a near vacuum. This extreme low pressure means that unprotected human exposure is instantly lethal, as bodily fluids would rapidly boil. This necessitates complete and unwavering reliance on robustly pressurized habitats and highly specialized suits for every moment of survival outside engineered enclosures. To gracefully counter the constant and pervasive cosmic radiation, intelligent and layered design is paramount for all Martian habitats. Radiation shielding could involve burying these structures deep under several meters of regolith, ingeniously utilizing the natural protective qualities of the Martian soil as a barrier. Alternatively, habitats might incorporate water-filled walls, as water is an excellent absorber of high-energy particles. Both methods offer crucial protection, but inevitably add layers of complexity and weight to habitat design and construction, requiring careful and elegant engineering solutions. As these settlements grow and new generations gently emerge, born under the reddish Martian skies, the first true inhabitants of Mars might naturally come to be known by distinctive new appellations, perhaps Martians or Aresians, reflecting their new planetary home. New terms, unique cultural expressions, and even a distinct linguistic cadence could gently emerge, shaping the language and self-perception of the inhabitants of humanity's second home, marking a quiet and profound evolution of human identity, a new branch on the tree of humanity. Beyond the immediate needs and profound experiences of the colonists, Mars colonization holds the promise of remarkable global benefits for Earth. It could gracefully lead to breakthroughs in sustainable living practices and innovative resource management techniques, with invaluable lessons directly applicable back on our home planet. The sheer necessity of extreme efficiency and self-reliance in the harsh, resource-limited environment of space can inspire ingenious and elegant solutions for Earth's own environmental challenges, fostering a more sustainable and harmonious future for all humanity. Looking to specific and advantageous locations on the Martian surface, the vast canyons of Valles Marineris, an immense geological feature stretching thousands of miles across the planet, offer compelling potential sites for sheltered habitats. These deep, winding valleys naturally provide some measure of protection dust storms, creating naturally advantageous and tranquil locations for pioneering settlements, nestled safely within the planet's grand geological embrace. Despite all meticulous planning and habitat design, external cosmic events remain a subtle yet potent threat. Sudden solar flares and powerful coronal mass ejections, gracefully erupting from the Sun, pose intense and immediate radiation hazards for Mars missions and surface operations. Robust early warning systems and easily accessible, deeply shielded shelters would be absolutely critical during such transient yet formidable solar outbursts, ensuring the swift and serene safety of colonists from these fleeting surges of energy. Within the protective confines of Martian habitats, efficient and sustainable food production is a key pillar of long-term viability. Growing food in vertical farms, utilizing stacked layers of crops under controlled lighting, could maximize both space and efficiency. This innovative technique optimizes yield in compact environments, ensuring a steady and diverse supply of fresh produce while minimizing the physical footprint required for agriculture, a crucial aspect of sustainable and serene living on Mars. Finally, the planet's most striking and iconic feature, its distinct reddish hue, comes from the pervasive presence of iron oxides, essentially rust, found within its surface rocks and fine dust. This ubiquitous coloration gently gives the planet its iconic red planet appearance, a visual reminder of the slow, patient chemical processes that have shaped its ancient surface over billions of years, creating a truly unique, serene, and recognizable landscape that welcomes our gaze. Within this distinct environment, the human element becomes paramount. The psychological effects of living in confined spaces for extended periods are a significant and subtle concern for any Martian settlement. Mission designers must meticulously consider every aspect of habitat layout, carefully allocating personal space and thoughtfully integrating recreational options to foster well-being. Ensuring mental tranquility and social harmony among colonists, far from the familiar comforts of Earth, will be as vital as the physical infrastructure itself. To truly establish a robust and enduring presence, developing independent manufacturing capabilities on Mars is absolutely crucial for achieving long-term self-sufficiency. The ability to produce spare parts, fabricate tools, and construct essential equipment locally without constant reliance on resupply missions from Earth will be the cornerstone of a thriving Martian industry. This localized production will allow the colony to grow organically and adapt to unforeseen needs, fostering a quiet sense of independence and resilience. Beneath the reddish surface, Mars experiences what scientists gently call Mars quakes, subtle seismic activity that, while not as dramatic as Earth's earthquakes, could potentially be harnessed as a source of geothermal energy. Studying these gentle tremors not only provides valuable insight into the planet's internal structure and geological processes, but also offers a potential quiet energy reservoir for future colonists, adding another layer of self-reliance to their energy portfolio. As human civilization extends to Mars, profound societal questions will inevitably arise. The legal status of children born on Mars, for instance, would need to be carefully defined by evolving international law. Questions of citizenship, planetary allegiance, and fundamental human rights would emerge, gently challenging our Earth-centric legal frameworks and paving the way for new principles of cosmic governance. This quiet legal evolution will shape the very foundation of a new society. In the most ambitious long-term visions for terraforming Mars, scientists ponder concepts that reach far beyond the planet's immediate resources. This might involve the majestic redirection of comets or asteroids, guiding these icy celestial bodies through space to deliver vast quantities of water and essential atmospheric gases to Mars. This highly ambitious concept would demand immense feats of engineering and a profound mastery of orbital mechanics, patiently reshaping a world over grand cosmic timescales. The celestial dance between Earth and Mars dictates the rhythm of our interstellar connections. Mars's distance from Earth varies significantly throughout their respective orbits, directly impacting optimal mission windows and the aforementioned communication times. The intricate principles of orbital mechanics gracefully dictate specific launch windows for efficient travel, ensuring that journeys are as brief and energy-conserving as possible, a testament to the elegant precision of celestial mechanics. Beyond the practicalities, the very act of colonizing Mars possesses a powerful, inspiring allure. It could gently ignite a new generation of explorers, scientists, and innovators across Earth. The promise and profound challenge of establishing a human presence on a new world could spark an immense passion for STEM fields, science, technology, engineering, and mathematics, fostering curiosity and driving progress for decades to come, a silent call to adventure. Revisiting the planet's material wealth, the pervasive Martian regolith, or surface dust and rock, can be carefully processed to extract valuable metals like iron, crucial for local manufacturing and robust construction. This local metal production would form a cornerstone of Martian industry, reducing the need for costly imports from Earth and allowing for the organic growth of infrastructure and technology on the red planet, fostering true industrial autonomy. Maintaining a robust and continuous communication infrastructure between Earth and Mars is absolutely critical for the success and safety of any mission. This intricate network involves a constellation of relay satellites orbiting Mars, diligently beaming data, and advanced deep space networks on Earth, listening intently across the vast distances. This seamless flow of information is essential for mission control, scientific data transfer, and the psychological well-being of colonists, a constant, gentle thread connecting two worlds. A unique and poignant aspect of Martian exploration is the lasting legacy of human presence. The very first human footprints left on the dusty surface of Mars would be preserved for millions of years, an enduring testament to humanity's reach. Due to the planet's almost complete lack of erosive wind and rain, these delicate impressions would remain virtually untouched, offering a lasting, silent legacy for early explorers and inspiring future generations with their quiet permanence. Understanding Mars's current state requires acknowledging a fundamental difference from Earth. Mars gracefully lacks a significant global magnetic field, unlike our home planet. This absence leaves its thin atmosphere perpetually vulnerable to the relentless erosion by the solar wind, a gentle yet persistent stream of charged particles from the Sun. This ongoing atmospheric stripping is a key reason for Mars's current thin atmosphere, shaping its arid and exposed environment over eons. For future colonists, long-term exposure to Martian dust poses a subtle yet significant respiratory health risk. The dust, being exceptionally fine, abrasive, and potentially containing toxic compounds, is a constant environmental factor that demands careful mitigation. Specialized air filtration systems and diligent cleaning protocols will be essential to protect the delicate respiratory systems of inhabitants from this pervasive and potentially harmful element. Beyond the scientific and technological feats, humanity's expansion to Mars represents a profound and quiet evolutionary and cultural shift. It could gently redefine what it truly means to be human as we gracefully evolve into a multi-planetary species. This monumental step extends our biological and cultural lineage beyond a single world, opening new horizons for self-perception, societal structure, and our collective destiny among the stars, a silent broadening of our very essence. In the early stages of establishing a Martian presence, efficient and adaptable housing solutions are paramount. Early Martian habitats might cleverly utilize inflatable structures, offering the benefits of quick deployment and significantly larger interior volumes once expanded after landing. These versatile structures provide more spacious and comfortable living and working spaces, allowing for rapid expansion and flexibility as the colony grows and evolves. Securing a continuous supply of water is a fundamental priority. Water extraction on Mars could involve gracefully heating subsurface ice deposits, causing them to sublimate directly into vapor, which is then collected. Alternatively, innovative methods might involve filtering the sparse atmospheric water vapor, though this is a less abundant source. Different extraction methods would be employed based on local geological conditions and energy availability, ensuring this precious resource is always accessible. Finally, Mars presents a striking and dynamic seasonal display through its polar ice caps. These magnificent caps are composed of both water ice and frozen carbon dioxide, often referred to as dry ice. These vast ice formations are dynamic, gracefully shrinking and growing with the changing Martian seasons, a beautiful testament to the planet's subtle yet powerful climatic shifts. These caps represent not only a key water source, but also a visible marker of the planet's elegant seasonal rhythm, a quiet dance of ice and atmosphere. To ensure the long-term viability of any human endeavor here, the meticulous development of closed-loop recycling for all waste products is absolutely essential for a truly sustainable Mars colony. This comprehensive approach means that everything, from human waste and wastewater to industrial byproducts and atmospheric contaminants, must be carefully processed and reintegrated into the colony's resource cycles. This continuous purification and reuse system forms a vital, self-sustaining loop, minimizing waste and maximizing efficiency in a resource-constrained environment, allowing for serene and responsible habitation. Such an immense undertaking, the colonization of Mars, inherently fosters unprecedented international cooperation and the graceful sharing of resources and knowledge. A project of this profound scale and complexity would likely require the harmonious collaboration of global entities, uniting nations and private ventures in a shared vision for humanity's future beyond Earth. This collective effort transcends terrestrial boundaries, embodying a spirit of peaceful and shared exploration. Central to the vision of terraforming is Mars's atmosphere itself, which is composed of approximately 95% carbon dioxide. This abundant greenhouse gas, while currently contributing to the planet's cold and arid state, could be ingeniously utilized for warming the planet. Its pervasive presence is a key element in future plans for atmospheric engineering, offering a natural resource to initiate a gentle, gradual planetary transformation. During the extensive transit to Mars, radiation exposure remains a major concern for the well-being of astronauts. To mitigate this risk, spacecraft designs incorporate carefully shielded sleeping quarters, providing a measure of protection during the months-long journey through the silent, radiation-filled void of deep space. These protected areas offer a tranquil refuge, safeguarding the health of the pioneering crew. Upon arrival, and within the controlled environments of greenhouses, the first plants cultivated on Mars will likely be hardy. Fast-growing crops, such as various types of lettuce, robust potatoes, or nutrient-rich algae, these resilient species would be rigorously tested for their viability and yield in the unique Martian conditions, forming the foundational elements of a sustainable and diverse food supply for the pioneering colonists, ensuring sustenance with quiet efficiency. In terms of physical scale, Mars is gracefully about half the diameter of Earth, yet its total surface area is remarkably similar to the combined landmass of Earth's continents. This provides a truly vast and expansive new frontier for human settlement, offering immense space for exploration, expansion, and the establishment of numerous colonies without the constraints of limited territory, a silent, open invitation to growth. The economic model for Mars colonization will need to be carefully crafted to ensure its long-term viability. This could involve the development of specialized resource exports back to Earth, such as rare minerals or advanced materials, or the establishment of specialized manufacturing industries that produce unique products in the low-gravity, high-vacuum environment. Creating tangible value on Mars will be absolutely necessary for its sustained economic independence and growth, weaving a new thread into the fabric of human commerce. To assist human colonists in their demanding tasks, robotic assistants and drones will play a crucial and invaluable role in construction, exploration, and the ongoing maintenance of infrastructure on Mars. Automating dangerous, repetitive, or arduous tasks enhances both the safety and efficiency of operations, freeing human colonists to focus on more complex decision-making and scientific pursuits, creating a harmonious partnership between human ingenuity and automated precision. Establishing a truly permanent and self-sustaining human presence on Mars is not a rapid endeavor. It is a patient marathon of technological and human development that could take several decades of sustained effort and unwavering commitment. It is not a quick sprint to a finish line, but rather a deliberate, continuous journey of growth, adaptation, and innovation, unfolding gracefully over time, a testament to long-term vision. The low atmospheric pressure on Mars has a unique and subtle impact on daily life. Water boils at a much lower temperature than on Earth. This fundamental difference affects everything from the preparation of food and beverages in cooking to personal hygiene practices and even various industrial processes that rely on heating and cooling, requiring careful adjustments to familiar routines and technologies. Due to its thin atmosphere, Mars lacks a significant protective blanket to effectively burn up incoming meteoroids. This absence leads to a relatively frequent occurrence of surface impacts from small celestial bodies. Consequently, habitats will need robust protection from these small but numerous impacts, requiring resilient designs and proactive defensive measures to ensure the safety and longevity of Martian settlements. For those colonists who gaze back at Earth from their distant Martian home, the overview effect might evoke a profound and complex sense of both isolation and deep wonder. Seeing Earth as a distant, luminous blue marble, a solitary jewel in the vast cosmic ocean, could stir unique emotional responses, a blend of longing for home and an awe-inspiring appreciation for the singular beauty and fragility of our origin planet. To ensure the continuous and seamless operation of a Martian colony, autonomous systems will gracefully manage many essential functions, from the intricate power grids and environmental controls to the vital life support systems, often with minimal direct human oversight. This reliance on intelligent automation ensures continuous operation, frees human colonists for more specialized tasks, and enhances the overall efficiency and resilience of the settlement, allowing for a quiet, underlying harmony in complex systems. Mars's thin atmosphere also results in a notable lack of significant weather systems that produce rain or snow as we know them on Earth. While dynamic dust devils gracefully swirl across the surface and planet-engulfing dust storms can occur, the gentle precipitation of liquid water or crystalline ice is largely absent. This creates an arid, quiet landscape, distinct from Earth's more varied and often wetter atmospheric cycles. The colonization of Mars is an undertaking of immense proportions, one that would require a massive initial investment of resources, likely drawn from a harmonious combination of international governmental bodies and visionary private sources. Funding such an ambitious and long-term project represents a truly global challenge, demanding collective commitment and shared financial stewardship to bring this cosmic dream to fruition. Finally, Mars also exhibits its own atmospheric phenomena, including polar vortices. These swirling masses of cold air gracefully form over its poles, similar in principle to those found on Earth. These dynamic weather patterns subtly influence atmospheric circulation across the planet, adding another layer of intricate complexity to Mars's climate system, a quiet dance of air and temperature in the high Martian latitudes. Beyond these atmospheric intricacies, the very surface of Mars itself tells a profound story through its numerous impact craters. These ancient scars, etched across the reddish landscape, testify silently to its long, unprotected history, a time when celestial wanderers frequently pierced its thin atmosphere. Each crater offers quiet clues about the early solar system, a gentle echo of cosmic events, and provides valuable insights into the planet's deep geological past, revealing the forces that shaped its surface over billions of years. The low density of Mars's atmosphere also profoundly affects the way sound travels across its quiet expanses. Sounds would be much fainter and travel more slowly than they do on Earth, creating an acoustically hushed environment. Consequently, conversations among colonists on Mars would often require closer proximity or the graceful assistance of communication devices to bridge the silent distances, fostering a unique and intimate form of interaction. For strategic and protective reasons, future colonists might thoughtfully choose to build their habitats within the natural embrace of craters or deep canyons. These majestic topographical features offer inherent advantages, providing natural shielding effects of dust storms. Such sheltered locations represent wise choices for protective settlement, blending human ingenuity with the planet's own ancient architecture. Mars's average distance from the Sun is approximately 142 million miles, a significantly greater separation than Earth's 93 million miles. This increased distance is a fundamental factor, gently contributing to Mars's colder temperatures and the reduced solar energy available for power generation. This cosmic positioning shapes the planet's climate and energy budget, necessitating advanced technologies to compensate for the dimmer sunlight. The first generation of Mars settlers will embark on a journey filled with unprecedented challenges, requiring an immense wellspring of resilience, adaptability, and quiet fortitude. Their pioneering experiences, their successes and their struggles will gracefully lay the foundational blueprint for all future Martian inhabitants, shaping the culture, technology, and spirit of humanity's new home for generations to come, a silent legacy unfolding. During the Martian day, the sky above the reddish landscape takes on a distinct reddish-orange hue. This unique atmospheric effect is due to the fine dust particles perpetually suspended in the air, which gracefully scatter sunlight in a particular way. This creates a visually distinct and serenely beautiful environment for colonists, a constant reminder of their unique place in the cosmos, painting the sky with warm, subtle tones. To support complex operations and enhance safety, advanced robotics and sophisticated artificial intelligence will be absolutely critical for automating a wide array of maintenance and exploration tasks on Mars. Autonomous systems can gracefully perform dangerous, tedious, or repetitive work, thereby significantly enhancing human safety and overall mission efficiency, fostering a harmonious and productive partnership between human intelligence and machine precision. Finally, while Martian dust storms are undeniably powerful and visually dramatic, they are not as destructive as Earth's mighty hurricanes. This subtle difference is due to the very thin atmosphere of Mars. Although visibility can be severely reduced during these events, creating an eerie, obscured landscape, the actual force of the wind is considerably less impactful than its terrestrial counterparts, allowing colonists to weather these atmospheric events with a greater sense of calm and managed risk. Yet, even in the quiet aftermath of a dust storm, a fundamental vulnerability of Mars persists. The pervasive absence of a global magnetic field on the red planet leaves it perpetually exposed to a constant, gentle shower of charged particles emanating from the solar wind. This continuous cosmic stream gracefully contributes to the slow, patient escape of its delicate atmosphere over eons and bathes the surface in pervasive radiation, a silent, ever-present environmental factor that demands robust protection for any future inhabitants. This lack of a planetary shield is one of the most significant challenges, shaping every aspect of life and construction on Mars, necessitating innovative solutions to create safe havens for humanity. To gracefully counter these relentless surface challenges, future Martian infrastructure might ingeniously include vast networks of underground tunnels for both transportation and the secure connection of habitats. These subsurface networks would offer protected, serene routes for movement between different parts of a colony and for the efficient transfer of vital resources, all shielded from the harsh radiation and the abrasive dust that characterize the surface. Imagine quiet passages linking domes and facilities, allowing colonists to move freely and safely beneath the surface, embracing the planet's subterranean potential. Such an intricate web of hidden pathways would provide a profound sense of security and continuity, a calm and protected environment unfolding beneath the reddish plains. These subterranean arteries would become the lifeblood of a growing Martian settlement, facilitating a tranquil, interconnected existence where the subtle hum of machinery replaces the distant whisper of the solar wind. The construction of these hidden arteries would be a monumental yet patient endeavor, carefully carved into the Martian crust, creating a sanctuary from the relentless cosmic elements. The very act of living beneath the surface would shape a unique Martian psychology, fostering a deep appreciation for enclosed spaces and the intricate network of systems that sustain life. This approach maximizes the natural shielding offered by the planet's own geology, providing a quiet strength against the vastness above. Within these carefully constructed environments, the experience of living on Mars would be uniquely altered by its lower gravity. Mars's gravitational pull is approximately 1/3 that of Earth's, a gentle difference that would allow humans to jump 3 times higher than they can on their home planet. This fundamental change would gracefully alter everyday physical activities, reimagining everything from movement and locomotion to the very nature of sports. Imagine effortless strides, graceful leaps, and entirely new forms of recreation designed to capitalize on this lighter gravitational field. This subtle shift in physics would not only make exploration more fluid, but would also inspire a new kind of physical grace, shaping the bodies and movements of Martian inhabitants in delicate, novel ways, fostering a unique physicality. The engineering of tools and personal equipment would also adapt, becoming lighter and more efficient, tailored to this low-gravity ballet. Beyond the physical adaptations, the very act of colonizing Mars could profoundly inspire new forms of art, music, and literature unique to the Martian experience. The stark beauty of the red landscape, the distant blue marble of Earth, the quiet isolation, and the daily challenges of survival would collectively foster distinct creative expressions. Artists might capture the serene Martian sunsets in hues never before imagined. Musicians might compose melodies echoing the planet's gentle hum, and writers might craft narratives of profound human resilience and interstellar destiny. This new environment would become a silent muse, nurturing a vibrant cultural awakening. A testament to humanity's enduring spirit of creativity, blossoming in unexpected ways under a foreign sky. The stories told, the songs sung, and the images painted would reflect a unique perspective, a new chapter in human artistic endeavor. To support this burgeoning civilization, the planet's natural resources offer crucial building blocks. Mars possesses significant deposits of iron ore, a valuable and abundant resource embedded within its reddish rocks. This raw material could be carefully extracted and smelted locally, providing the essential metals for manufacturing, constructing new habitats, and fabricating necessary tools. Local metal production would thus become a foundational cornerstone of Martian industry, reducing the colony's reliance on costly imports from Earth and fostering a deeper sense of self-sufficiency. This quiet industrial process, transforming native rock into usable material, would symbolize the growing independence of the Martian settlement. Such a monumental and ambitious undertaking, the establishment of the first permanent human settlements on Mars, may very well evolve as a grand international collaboration. Sharing resources, pooling expertise, and harmonizing technological advancements would significantly benefit from a global partnership, uniting diverse nations and scientific communities in a common, peaceful purpose. This collective endeavor, transcending national borders, would embody a spirit of shared human destiny, a serene testament to our ability to work together for a future beyond Earth. Such a cooperative model would mitigate risks, share the immense financial burden, and foster a truly global Martian identity, demonstrating humanity's capacity for unity on the cosmic stage. However, even with advanced infrastructure and international cooperation, the Martian environment presents persistent challenges. Mars's surface temperature can fluctuate dramatically, often by over 100 degrees Fahrenheit between the peak of day and the chill of night. This extreme thermal cycling requires exceptionally robust materials and habitat designs, capable of gently expanding and contracting without structural fatigue, maintaining a stable and comfortable internal environment for colonists despite the external extremes. The patient engineering required to withstand these daily thermal stresses is a testament to human ingenuity. Finally, as humanity ventures to Mars and eventually returns, a profoundly important ethical and scientific imperative guides every mission. Protecting Earth from potential Martian biological contamination is a strict and unwavering requirement for all return missions. Rigorous sterilization protocols are meticulously in place to prevent the transfer of any alien microbes, however theoretical, back to our home planet. This careful, proactive approach safeguards Earth's delicate biosphere, ensuring that our cosmic explorations remain a gentle and responsible journey, preserving the sanctity of both worlds. This quiet vigilance reflects a deep respect for life, both known and unknown. As we contemplate such profound responsibilities, Mars itself gracefully offers a rich and unparalleled scientific laboratory, a silent world waiting to reveal its secrets. It presents an extraordinary opportunity for studying the grand narrative of planetary evolution and, most compellingly, for investigating the potential for extraterrestrial life, however simple. Its unique geological history, etched with the passage of eons, and the compelling evidence of past liquid water on its surface, make it a prime and captivating target for meticulous research. This quiet pursuit of knowledge is a testament to humanity's innate curiosity. The very concept of transforming Mars into a more Earth-like world, known as terraforming, has long captivated the human imagination, explored for decades within the pages of science fiction. These imaginative narratives have now transcended their fictional origins, gracefully inspiring real scientific proposals and engineering blueprints. It is a beautiful and often observed phenomenon that fiction frequently precedes scientific ambition, gently shaping our collective visions for the future and guiding our aspirations toward what was once considered impossible. The dreams of yesterday quietly become the scientific endeavors of today. Adding to the planet's allure for such grand visions, Mars holds within its ancient landscapes numerous well-preserved river valleys and expansive lake beds. These elegant geological features stand as strong, silent evidence of a distant past when liquid water flowed freely and abundantly across its surface. Such compelling features gently suggest that Mars once enjoyed a much warmer and wetter climate in its distant past, hinting at a more clement environment that could, with diligent effort and advanced technology, one day be coaxed back into existence. These ancient waterways are quiet echoes of a different time. Yet, before any long-term habitation or terraforming can truly take root, the journey to Mars itself remains a monumental test of human endurance. This arduous voyage requires not only immense physical stamina, but also meticulous mental preparation from every astronaut. Crews must be highly trained to gracefully cope with the profound demands of deep space travel, including prolonged confinement, the subtle effects of microgravity, and the pervasive radiation environment. Their quiet strength and resilience will be the foundation of mission success, a testament to the human spirit's capacity for sustained effort. Upon arrival, the current state of Mars's atmosphere presents an immediate and fundamental challenge to any vision of surface water. The planet's atmosphere is simply too thin and tenuous to sustain liquid water on its surface for more than fleeting moments. Any exposed liquid water, whether from a melted ice deposit or a rare flow, would quickly and gracefully evaporate into the near vacuum or instantly freeze due to the low pressure and extreme cold. This delicate atmospheric balance dictates that water must be carefully contained and managed. For future Martian colonies to thrive and become truly self-sufficient, they will need to develop comprehensive and highly efficient waste management and recycling systems. Every single byproduct of human activity, from organic waste to industrial effluents, must be meticulously processed, purified, and reintegrated into the colony's closed-loop resource cycles. Maximizing resource recovery, ensuring that nothing is truly wasted, is absolutely essential for long-term sustainability within a confined and precious environment. This intricate process ensures a continuous, harmonious flow of resources. A deeply iconic feature of Mars, its distinct reddish coloration, is due to the pervasive presence of iron minerals on its surface that have oxidized over billions of years, much like the familiar process of rust forming on Earth. This pervasive and ancient rust signature that has captivated humanity for millennia. This subtle chemical transformation paints the entire landscape in warm, ruddy hues, creating a unique and recognizable backdrop for any future human endeavor. Finally, the grand vision of establishing a truly self-sufficient and independent human presence on Mars is not a task for a single generation. It is a patient and profound generational endeavor that could gracefully take several centuries to achieve. This long-term commitment requires an unwavering, sustained vision and immense, continuous effort from humanity as a whole. It is a quiet, deliberate march through time, building a new home for our species, one careful, thoughtful step at a time, a testament to humanity's enduring dreams for the cosmos. Within this grand vision, the planet's dynamic features offer both resources and challenges, a delicate balance for future inhabitants to navigate with grace. Mars has magnificent polar ice caps that gracefully grow and shrink with the changing seasons, a silent, rhythmic breath of the planet. These vast, luminous caps are composed of both precious water ice and substantial quantities of dynamic, ephemeral features represent a major and accessible source of water, a fundamental resource that can be extracted and meticulously purified for drinking, for generating breathable oxygen through patient electrolysis, and for producing rocket fuel, enabling self-reliant exploration and travel. The gentle waxing and waning of these caps with the Martian year provide a clear and elegant indication of the planet's climatic cycles and offer a visual reminder of the planet's vast, frozen reserves, waiting to be gently harnessed for human needs, a quiet promise of sustenance in an arid world. Their serene, almost sculptural presence against the reddish landscape offers a poignant reminder of both the challenges and the opportunities that Mars presents for humanity's future. The careful management of these vital ice reserves will be a continuous, patient task, ensuring the long-term viability of any settlement. Beyond the physical resources that Mars so generously offers, the very act of colonizing this distant world could gracefully provide a unique and invaluable opportunity to meticulously study the long-term effects of its lower gravity on human biology. With Mars's gravitational pull being approximately 1/3 of Earth's, pioneering colonists will live and work under conditions that differ profoundly from our home planet. This sustained exposure to reduced gravity will allow scientists to observe, with great care and precision, the subtle yet profound physiological adaptations of the human body over extended periods. This critical research would have far-reaching implications for all future deep space travel, informing the refined design of spacecraft and habitats, and facilitating the development of effective countermeasures to mitigate any adverse health effects for astronauts undertaking even longer journeys to distant stars. Understanding how the human body gracefully adapts and thrives in such an environment is fundamental to humanity's enduring presence in the cosmos, a silent, grand experiment unfolding within a new planetary laboratory, revealing the remarkable resilience of life itself. The insights gained here would delicately guide our further ventures into the universe, ensuring the well-being of future generations of spacefarers. Amidst these grand scientific inquiries and intricate resource management strategies, the Martian surface itself presents a fascinating array of microclimatic phenomena. Mars experiences frequent dust devils, graceful, swirling columns of air and dust that gently traverse the reddish landscape with an almost ethereal quality. While these small atmospheric phenomena can pose minor challenges for surface operations by temporarily obscuring visibility and depositing fine particulates, they also offer a surprising and remarkably beneficial service. They can naturally clean accumulated dust from solar panels. As these miniature whirlwinds pass over arrays, their gentle currents effectively remove accumulated regolith, significantly enhancing the efficiency of power generation and reducing the need for manual cleaning by human colonists. These dynamic, localized events highlight the intricate interplay of Mars's thin atmosphere and surface, offering both subtle challenges and unexpected advantages for daily life and critical operations, a quiet dance of wind and dust that can paradoxically assist human endeavors. Their fleeting presence is a constant, subtle reminder of the planet's atmospheric activity. To ensure the utmost safety, the highest efficiency, and the long-term viability of complex Martian operations, the meticulous development of advanced robotics, capable of sophisticated self-repair and executing intricate tasks autonomously, will be absolutely crucial. These intelligent machines are envisioned to gracefully perform a wide array of duties, from the initial, demanding stages of construction and extensive exploration of new terrains to the routine and often monotonous maintenance of intricate infrastructure, all with minimal direct human intervention. Autonomous systems are designed to handle dangerous or tedious work, thereby significantly enhancing human safety by reducing colonists' exposure to the harsh, unforgiving environment and freeing them to focus on more creative, scientific, and strategic endeavors. This harmonious partnership between human ingenuity and robotic precision will be a cornerstone of a thriving Martian civilization, a silent, tireless workforce supporting humanity's grand dreams with unwavering dedication and meticulous care. The quiet whir of these robots will be a constant companion in the Martian landscape. Underlying all these ambitious plans and technological advancements is Mars's fundamental nature as a terrestrial planet. This means it possesses a solid, rocky surface, much like Earth, Mercury, and Venus. This intrinsic characteristic fundamentally makes it a suitable candidate for human settlement, providing a stable and unyielding foundation upon which to build habitats, establish laboratories, and explore a tangible, familiar kind of world. Unlike the gaseous giants of our solar system, which offer no solid ground, Mars provides a firm and reassuring platform for humanity to stand upon, a quiet, welcoming solidity in the vastness of space. This geological stability is a crucial prerequisite for establishing any long-term, self-sufficient colony, offering a sense of permanence and a sturdy base for growth and expansion. The initial phase of Mars colonization is envisioned not as a sudden, sprawling expansion, but as a careful and measured progression, involving the establishment of small, modular habitats that can be gracefully expanded over time. This phased approach allows for gradual growth and thoughtful adaptation, enabling pioneering colonists to meticulously test technologies, refine operational procedures, and slowly but surely build out their infrastructure in a systematic and sustainable manner. Beginning with compact, essential living units and then adding modules as needed fosters resilience and flexibility, ensuring that the colony evolves organically and securely, a patient unfolding of human presence. This incremental development allows for lessons learned to be immediately applied. creating a robust and adaptable pathway towards a larger settlement, a gentle and controlled expansion into a new world. Within these growing settlements, Mars's atmosphere, which is predominantly composed of carbon dioxide, becomes an unexpected yet profoundly valuable asset for sustaining life and fostering growth. This abundant atmospheric gas can be efficiently harvested and then ingeniously utilized for plant growth within carefully controlled greenhouses. Carbon dioxide is a fundamental requirement for photosynthesis, the very process by which plants convert light into energy, making the Martian atmosphere a readily available and indispensable resource for Martian agriculture. This direct utilization of local atmospheric components elegantly closes another critical loop in the life support system, fostering self-sufficiency and reducing reliance on Earth-based supplies, ensuring a quiet, verdant productivity that transforms a challenging atmosphere into a source of life. The gentle hum of these greenhouses would symbolize hope and resilience. Ultimately, the colonization of Mars would represent a truly monumental achievement for humanity, a profound and inspiring expansion of our reach and influence beyond our home planet. It would signify far more than just a technological feat. It would gracefully mark a new and exhilarating chapter in human exploration and existence, fundamentally redefining our place in the cosmos. This grand endeavor, born of an innate curiosity and sustained by unwavering resilience, would stand as an enduring testament to our collective spirit of discovery. A quiet, powerful statement of humanity's limitless potential and our gentle, persistent journey among the stars. It is a future shaped by patient effort, profound vision, and a deep, quiet hope for what lies beyond. As we consider this journey, the precise cosmic geography of Mars plays an influential role in shaping its environment. Mars is gracefully positioned at an average distance of about 142 million miles from the Sun, a considerable span. In contrast, our home planet, Earth, orbits at a closer, more temperate average of about 93 million miles. This greater orbital distance for Mars is a fundamental factor that profoundly influences its climate, contributing to its colder temperatures and significantly reduces the amount of solar energy available for power generation. This delicate balance of distance and light dictates many of the engineering solutions required for sustenance and comfort on the red planet, a quiet cosmic truth shaping daily life. To ensure the well-being of colonists in this distant, unique environment, sophisticated psychological support systems will be absolutely vital. These systems will thoughtfully incorporate elements such as immersive virtual reality experiences, offering familiar sights and sounds of Earth, and facilitating regular, albeit time-delayed, communication with loved ones back home. Maintaining morale and nurturing mental health will be a top priority, recognizing the profound isolation and unique stresses of life on another world. These gentle connections and diversions will serve as anchors, supporting the emotional resilience of those living far from their origin. Gazing across the Martian landscape, one cannot help but be captivated by the sheer scale of the Valles Marineris Canyon system. This colossal geological feature is so immense that it could gracefully stretch across the entire United States, a truly breathtaking testament to ancient planetary forces. Beyond its immense geological complexity, this vast canyon offers compelling potential as a site for sheltered habitats. Its deep valleys and extensive cliffs could naturally provide significant effects of planet-wide dust storms, making it a strategically advantageous location for protective human settlement, a natural haven in a grand, ancient embrace. Delving beneath the surface, Mars reveals another subtle, yet significant difference from Earth. Mars has a thinner crust than our home planet, a geological characteristic that gently suggests a distinct internal structure and a different, perhaps less active, geological history. This variation in its deep internal dynamics directly affects its volcanic activity, which is now largely dormant, and its seismic patterns, manifesting as the subtle Marsquakes. Understanding these internal differences is crucial for comprehending the planet's evolution and for safely establishing long-term infrastructure. Building upon the wisdom of utilizing natural protection, future Martian cities might ingeniously be constructed into the sides of these very canyons, or nestled within mountains, rather than freestanding on open plains. This strategic placement would leverage natural topography for added radiation shielding, allowing the planet's own ancient structures to become silent guardians. Such a design approach optimizes safety and reduces the need for artificially manufactured shielding, blending human habitation harmoniously with the existing Martian landscape, a testament to thoughtful adaptation. The rhythm of life on Mars will also be shaped by its unique orbital period. Mars has a longer year than Earth, gracefully lasting about 687 Earth days. This extended orbital cycle directly impacts its seasonal cycles, meaning that colonists would experience seasons that are nearly twice as long as those on Earth. Adapting to this slower, more prolonged seasonal rhythm will require a gentle shift in agricultural planning, resource management, and daily routines, fostering a new appreciation for the passage of time on a cosmic scale. Looking toward a more distant future, the development of self-replicating robots or fully automated factories could profoundly accelerate Martian colonization. These sophisticated systems, capable of manufacturing components, constructing new facilities, and even creating more of themselves, would allow for an exponential growth of infrastructure with significantly less direct human labor. This would free human colonists to focus on scientific research, exploration, and the cultural development of their new home, ushering in an era of rapid, autonomous expansion, a quiet technological revolution on a new world. Finally, the very ground beneath their feet offers a fundamental resource. Mars's surface is remarkably rich in basaltic rock, a common volcanic rock type quite similar to much of Earth's own volcanic terrain. This abundant and versatile rock is highly useful for construction materials. It can be readily crushed, processed, and then utilized in a wide variety of building applications, from concrete aggregates to protective shielding, forming the very foundation of Martian structures. This local availability of a robust and versatile building material simplifies construction and reduces reliance on Earth-based imports, allowing for a more self-reliant and gracefully expanding Martian civilization. The colonization of Mars, however, extends far beyond the realm of engineering and resource management. It gracefully raises profound philosophical questions about human identity and our very place in the cosmos. The transformative step of becoming a multi-planetary species could profoundly and gently alter our collective self-perception, inviting us to reconsider what it means to be human, to belong to a world, and to exist within the vast, silent tapestry of the universe. This expansion gently challenges our Earth-centric view, fostering a new, broader understanding of our shared existence and potential destiny among the silent stars, a quiet and profound evolution of human consciousness. While Mars conspicuously lacks a global ocean, a defining feature of Earth, scientific explorations have graciously detected large underground reservoirs of water ice hidden beneath its reddish surface. These vast, hidden ice deposits are absolutely crucial for future resource extraction, offering a lifeline of potable water, a source for breathable oxygen, and a key component for rocket fuel. Their silent and immense presence beneath the arid plains represents a profound potential, awaiting careful and patient harvesting to sustain life and growth, a hidden treasure in a thirsty land, promising future oases of vitality. The extreme low atmospheric pressure on Mars means that specialized, rigorously pressurized habitats are not merely convenient, but absolutely essential for human survival. Without these meticulously engineered enclosures, unprotected human exposure would be immediately fatal, as the body's fluids, including blood, would rapidly boil in the near vacuum. This stark reality underscores the critical importance of robust habitat design and the diligent, constant maintenance of atmospheric integrity, ensuring a safe and stable environment for all inhabitants, a delicate bubble of life gracefully sustained against an unforgiving void. In a fortunate alignment of cosmic mechanics, Mars possesses a relatively stable rotation axis. This graceful stability leads to more predictable and consistent seasonal patterns compared to some other bodies in our solar system, which can experience dramatic axial wobbles. This inherent predictability greatly aids in the meticulous planning of agricultural cycles, resource management, and various surface operations, allowing colonists to anticipate environmental changes with a greater sense of calm and order, fostering a rhythmic harmony with the Martian year, a subtle planetary clock. The first generation of Mars settlers will, by their very nature, be true pioneers, embarking on an unparalleled journey. They will face unique challenges and profound responsibilities, laying the foundational stones and contributing their courage and ingenuity to the birth of a new human civilization. Their experiences, their triumphs and their struggles will gracefully shape the very history and the enduring ethos of Martian society for generations to come, leaving an indelible, silent legacy etched into the grand annals of interstellar expansion. The planet's average surface gravity is approximately 3.7 meters per second squared, a gentle pull significantly less than Earth's 9.8 meters per second squared. This reduced gravity will profoundly affect everything, from the long-term health of human bones and muscles, which will require careful exercise regimens and countermeasures to prevent density loss, to the physics of projectile motion, altering how objects fly and fall. This subtle yet pervasive difference will profoundly reshape daily life, inviting new forms of movement and activity, fostering a lighter, more graceful existence, and requiring innovative adaptations in human endeavors. Beyond the immediate challenges of habitation, the colonization of Mars holds the tantalizing potential for profound scientific discoveries. It could gracefully lead to the discovery of dormant or extinct Martian life, perhaps ancient microbial traces hidden deep beneath the surface, or even entirely new forms of chemistry, unlike anything known on Earth. Exploring this new world, with its unique geological and chemical history, holds immense and captivating scientific potential, promising revelations that could reshape our understanding of life's prevalence in the universe, a silent, cosmic quest for answers to fundamental questions. Contributing to its current arid state, Mars possesses a very thin exosphere, which is the outermost, most tenuous layer of its atmosphere. In this region, atmospheric particles can gracefully escape into the vastness of space, a slow and continuous process. This ongoing atmospheric loss, driven by the gentle solar wind and the lack of a strong magnetic field, gradually contributes to Mars's current dry and exposed state, a subtle cosmic erosion that has patiently shaped its environment over billions of years, creating the silent, dusty world we observe today. The long-term goal of Mars colonization extends far beyond merely establishing a temporary outpost or a research station. The ultimate vision is to create a fully self-sufficient, independent human civilization, capable of sustaining itself and growing without constant reliance on Earth. This grand aspiration encompasses economic autonomy, rich cultural flourishing, and the thoughtful development of unique Martian governance, a testament to humanity's enduring drive for self-determination and graceful expansion into the wider cosmos, a patient, profound journey towards independence. Mars experiences significant orbital eccentricity, meaning its path around the Sun is more elliptical than Earth's, causing its distance from the Sun to vary more dramatically throughout its year. This subtle yet important orbital characteristic directly affects the intensity of its seasons, making them more pronounced and variable than Earth's. Understanding this gentle ebb and flow of solar radiation is crucial for long-term planning, particularly for agriculture and energy management, ensuring harmony with the planet's celestial dance, a rhythm etched in its orbit. The establishment of a human colony on Mars would stand as an unparalleled testament to human ingenuity, our collective perseverance, and the timeless spirit of exploration that defines our species. It represents a pinnacle of scientific and engineering achievement, a bold and graceful step into the future. This monumental endeavor would symbolize humanity's capacity to overcome immense challenges, to dream beyond our home planet, and to gracefully forge a new destiny among the silent stars, a quiet, inspiring triumph of the human will and collective spirit. Finally, Mars offers a wonderfully diverse geology, a rich tapestry of plains, towering volcanoes, deep canyons, and dynamic polar caps. This geological richness provides an immense array of varied terrain for exploration, from ancient lava flows to sedimentary layers that whisper of past water. Each unique geological feature offers countless scientific opportunities, promising insights into planetary formation, geological processes, and the tantalizing possibility of past life. This varied landscape invites continuous discovery, a silent, captivating world waiting to be explored, inspiring wonder with its quiet beauty and deep history, a final, serene invitation to ponder our place in the cosmic story. And now, as our journey through the intricate facts of Mars colonization gently draws to a close, let the images of its diverse plains, silent volcanoes, and deep canyons softly recede. You have drifted through the careful planning for new homes, the ingenuity required to sustain life, and the profound questions that arise as humanity reaches for another world. We have explored the challenges of distance, the necessity of resilience, and the quiet hope for a future among the stars. As you settle deeper into this moment, imagine the subtle hum of a future Martian habitat, a tranquil haven beneath a reddish-orange sky. Picture the gentle glow of Earth, a distant blue marble, seen from the peaceful expanse of Mars. The cosmos continues its silent, majestic dance, with stars patiently forming, light serenely traveling, and galaxies gently merging across unimaginable distances. You are a part of this grand cosmic narrative, a small yet significant presence within this vast, radiant sea. The elements that compose your very being were forged in the hearts of ancient stars, and the air you breathe carries the whispers of cosmic history. Tonight, as you rest, let the quiet wonders of Mars and the universe envelop you in a sense of calm. Thank you for journeying through the cosmos tonight. I hope you sleep well and dream softly. Good night.